Okay, we're back to some more radicals this week. Last week we looked at how to simplify a radical and then also how to do some multiplying and dividing with radicals. You had a quiz over that stuff last week, and your graded quizzes are in OneNote. So make sure you go check out your grade on those, look at your mistakes. I've been writing a lot of corrections and stuff on quizzes and tests, so I hope you're going back into OneNote to see those comments so that you correct your mistakes and make them better. Okay, so today, adding and subtracting radicals. We'll look at this. It's a lot different than multiplying and dividing, but if we compare it back to what we're used to and the rules we know, it's not so bad. Okay, so first part here, this stuff in the box here, the distributive property, you guys know that very well. If we have A times the quantity B plus C, we can distribute in the A, that makes AB plus AC, right? Or vice versa, you've got the A on the other side. Okay, we can use that distributive property to simplify sums of radical expressions when the radicands, that's the number inside the radical, are the same. Okay, so it's very similar to doing like terms, and I'll kind of show you an example of that. But basically, if I look at 4 radical 7 and 5 radical 7, both of those have a factor of radical 7. So it's kind of like taking out a GCF almost, right? So I'm going to take out that radical 7, and then inside I would still have 4 plus 5. Now 4 plus 5, I can do that, right? That's radical 7 times 9. And then I'm just going to rewrite that as 9 radical 7. So in other words, if you've got 4 radical 7 and 5 radical 7s, if I add those together, I end up with 9 radical 7s. Very similar to like if I were to do 4x plus 5x, I get 9x, right? So don't add the numbers inside the radicals. We only add the coefficients in front. Okay, same thing here on this next one. I can group together the ones that have the common radicals, right? So we've got 7 radical 3 minus radical 3. I'm just going to reorder these by the commutative property. And then plus 2 radical 2 minus 3 radical 2. So now I've got my kind of like terms grouped together. This first set, I can take out a radical 3, and I'm left with 7 minus, there's a 1 in front of that other one. And then over here, I can take out a radical 2, and I'm left with 2 minus 3. Oops, that's the wrong number there. 2 minus 3. Okay, so then 7 minus 1, that would give me 6. So I get 6 radical 3. And then 2 minus 3 over here would give me negative 1. So I'd have minus 1 radical 2. Now, I can't do anything else with this, right? It's a lot like if I had, again, if you want to think like 7x minus x plus 2y minus 3y, we'd end up with 6x minus y. I can't do anything else with that. Same thing if you have radicals. So because they're different numbers inside the radical, that's all I can do. So my answer is 6 radical 3 minus radical 2. Okay, so very similar to just combining like terms. It's just that instead of x's and y's or a's and b's, we have radicals. And you can only add or subtract them if they have the same number inside the radical. Okay, okay, sometimes we want to do that same process of adding or subtracting, but none of our radicals are the same. However, sometimes you can simplify a radical, so then you do end up with radicals that are the same. Okay, so if I take this first one, for instance, we've got 7 radical 3 minus 4 radical 6. I'm not going to be able to do anything with 3 and 6, right? If I do factor trees for those, it doesn't get me anywhere. That's as simple as those get. But the 48 and then 54, I can break those down and simplify them. Okay, so I'm going to kind of take over here to the side. If I do radical 48, that I can do my tree, and I get, let's see, 12 and 4. 4 is a 2 and a 2. 12 is a 4 and a 3. And another 2 and a 2, right? So then again, you're looking at all your prime factors here. So this could become, so I've got a 2 squared, got another 2 squared, and I've got a 3. And remember, you want to do them in squared pairs, right? That way you can take the square root. So square root of 2 squared, that's 2. Square root of my other 2 squared, that's 2. And then the 3 is by himself, he doesn't have a pair, so the 3 stays in the radical. So that is actually 4 radical 3. Okay, then I'm going to do the same with my 54. 54 I can break down to 9 and 6. This is 3 and 3. This is 2 and 3. Okay, so then I want to do in pairs. So I've got a pair of 3's here, so that'd be a 3 squared. And then I just have a 2 and a 3 by themselves, so 2 and 3. Okay, so the square root of 3 squared, that 3 gets to come outside. But then I can't do anything with the 2 and the 3 because I don't have pairs, so 2 times 3 is 6 on the inside. Okay, so now I'm going to rewrite my expression over here as 7 radical 3 minus 4 radical 6 plus 2, but then instead of radical 48, we've got 4 radical 3. And then minus 6, and instead of radical 54, I've got 3 radical 6. Okay? All right, now I've got some things I can multiply. If I'm doing 2 times 4 radical 3, right, let's simplify those. So that will give me 8 radical 3 minus 18 radical 6. And now notice we've got like terms, right? I've got a radical 6 and a radical 6. And I also have 2 sets of radical 3's. So if we combine our like terms, I'm not going to write it all out in order this time, but if we just combine our like terms, a 7 radical 3 plus 8 radical 3 would give us 15 radical 3. And then a negative 4 radical 6 and a negative 18 radical 6 would give us a negative 22 radical 6. So coefficients in front change, number inside the radical stay the same. Okay, so we're kind of putting together what we did before. Sometimes you see each radical, and then when you put them back in, you end up with like terms. I can't do anything else because the 3 and the 6 are different, so that's our final answer there. Okay, and guys, when you do these problems, I should see about this much work. I should see these factor trees over here, or whatever. If you're using the, like, I know this is radical 4 times radical 12, which is 2 times radical 12, and then this is radical 4 times radical 3. You can do it that way, but I should see work that shows that you're not just using your calculator on these, okay? Because if we were doing this in class, you wouldn't have a calculator. All right, the next part, same thing here, right? I've got a radical 2, a 27, and an 8. Again, none of those match, but I can try to simplify each one to see if that gets us somewhere. So we'll take the 2. I'm not going to be able to simplify that one, so I'll leave it alone. We'll try the 27. That one I can do 9 and 3. It's 3 and 3. So I get the square root of, in pairs, 3 squared times 3. So then a 3 gets to come outside, the other 3 stays inside. And then let's try our 98. We can break that down. Oh, we'll just start with 2. And that would be 46. Nope. That's not right. 49. And then 49 is 7 and 7. So we've got 7 squared times 2. So we get 7 radical 2. Okay, and then we'll replace those in our original expression. So 25 radical 2 plus 2 times 3 radical 3 minus 3 times 7 radical 2. And then if we multiply, that'll give us 6 radical 3 minus 21 radical 2. And again, we look for our like terms. The only 2 I can combine are the 25 radical 2 and the negative 21 radical 2, which would give us 4 radical 2. And then that plus 6 radical 3. And again, I now have different numbers inside my radical. I can't do anything else, so we're done. Ta-da! Okay, there's some adding and subtracting with radicals. Okay. A few more here that just look a little bit different and require some other steps. The radical 15. If I try to break down 15, I just get 3 and 5, right? There's no pairs to match up there, so I can't simplify the 15. Radical 3/5. Again, I can't break down the 3 or the 5, so maybe there's something else we need to simplify here. And the only problem I see is that that fraction is inside the radical. So I'm going to start by rewriting this. Oops, not equals. As radical 15 minus, and I'm going to split that apart. So radical 3 over radical 5, right? And then I can see my problem is I don't want this second one to have a radical in the denominator. So I'm going to multiply by radical 5 over radical 5. Remember, this is called rationalizing the denominator, right? So then we keep our radical 15. And then on the top, radical 3 minus radical 5. I'm sorry, radical 3 times radical 5 would give us radical 15. And then on the bottom, radical 5 times radical 5 would be radical 25, which is just 5, because the square root of 25 is 5. Okay, so now I've got that taken care of, but now I notice something else. Both of my things have a radical 15. That's a good sign. That means I can actually do that subtraction, right? But now in order to do my subtraction, I need a common denominator. So I'm going to get this guy over here, the radical 15, to have a 5 as its denominator. Oops, I lost my radical. Right, so we're going to multiply that by 5. Okay, so then on the top I would get 5 radical 15 over 5 minus radical 15 over 5. Now they have a common denominator and they have the same radical in the numerator, right? So if you wanted to, you could rewrite this all as one fraction, 5 radical 15 minus radical 15 all over 5. And now I can do that subtraction on the top. Remember, there's a 1 in front of that one. So 5 radical 15s minus 1 radical 15 would give us 4 radical 15. And on the bottom, we still have our common denominator of 5. I can't simplify the 15 and the 5 because the 15 is inside, the 5 is outside, and then the 4 and 5 don't reduce. So that's our final answer. Okay. So again, sometimes if you do some other work with your radical, you can end up with something that actually will subtract. Okay, and our last one here, maybe. There it goes. And there was one kind of like this on one of the homeworks for you to kind of try out and see how you did. This one, we've got some distributive property going on. So we've got a radical on the outside, and then we have some subtraction inside. Now, I can't do radical 15 and radical 5. I can't do that subtraction because they're not the same number. So my only option here is to actually distribute the outside number, right? So when we multiply radicals, remember you can multiply outside numbers and you can multiply inside numbers. So I'm going to put a 1 here so I know that that's there. So I'm going to distribute my 3 times 1. That would give us a 3 on the outside. Radical 5 times radical 15 would give us a radical 75. And then I'm going to distribute to the other one. So 3 times negative 2 gives us a negative 6. And radical 5 times radical 5 gives us radical 25, right? And then right away I notice, hey, radical 25, that's a perfect square. So now I've got 3 radical 75 minus 6 times just 5, right? And then also I can take this radical 75 and break it down. So we can make that 15 times 5, and that's 5 times 3, which means we've got radical 5 squared times 3. So that is actually 5 radical 3. And then just don't forget we had our 3 out here in front, so it goes out there. And then minus 6 times 5 is 30, right? Okay, so then that gives us 15 radical 3 minus 30. And we can't do any other subtracting because we don't have common radicals, right? But we were able to distribute and simplify that, even though we couldn't actually subtract them. Okay, all right, so there's some examples on adding and subtracting radicals. Your homework today is on delta math. You've got a couple different sections to finish there. If you go through these notes and some of the stuff doesn't make sense, please send me a message on Google Chat or send me an email. I will get back to you as soon as I can with some clarification. to help you out. If you on the homework problem, same thing. If you're in the middle of Delta Math and you can't figure out how to do it by clicking the question mark or the show example, then send me a question and ask, and I'll help as soon as I can. Okay? All right, guys, have a good day. I will talk to you soon.